Hello everybody, welcome back to yet another video by JFB, and in this video we're gonna learn all about binary systems. So without wasting much time, let's dive into binary systems. So why are we learning binary systems? Well, because all computers actually, use binary systems to display information to you. Not only display, but also so they use information to display, and they also use that information to process. So all the things you see a computer do, it doesn't use numbers like the way we see it, like 5 or 6 or 117 or any of those numbers. In real sense, it just uses 1 0 1 0 0 0 1 1, all these types of numbers. It just uses 1 and 0 because those are the only things a computer can actually understand. If you go deeper into computer science, a computer basically just uses switches. That's all. And the switch can only be on or off. There is no middle part to this. A switch can always be on or it can be off. So that on can be represented by a 1 and that off can be represented by a 0. That's why computers mainly in their architecture only use 1s and 0s. So, moving on, we're gonna learn in this video how to convert from the Denary system. What is Denary if you don't know? This is the ordinary system which we use to count 1, 2, 18, 19, this system and all that. So we're gonna learn how to convert from Denary to binary. This conversion is important because of what I just said, that computers only use 1s and 0s, and you need to know how to convert these numbers. You see that later on when we move into data types Java, and you see the importance of learning why we need to know how to convert these numbers. So the Denary system uses base 10. That's all. And the binary system uses base 2. This is the only difference between these two systems. Denary base 10, binary base 2. So the numbers, if I was to say, increase from 10 to power 0 to 10 to power 1 to 10 to power 2 to 10 to power 3 to 10 to power 4, and they continue going on until infinity. For the binary system, the numbers increase from 2 to power 0, 2 to power 1, 2 to power 2, 2 to power 4, 2 to power 5, and 2 to power 6, 2 power 6, and they go on. So a typical number, let me give an example, like 108. This number, if you read it, it's called 108. 108. So it's standing in the 10 to the power 1, 10 to the power 0 place there, and the 0 is standing in the 10 to power 1 place there, and the 1 is standing in the 10 to power 2 place there. So let me give an example of a number in the Denary system. 256. This 256 is just read as 256, but breaking it up into the Denary system, it will be read as 10 to power 0 here, 10 to power 1 here, and 10 to power 2 here. If we further try to simplify this will be simply the 2, 100 here, 5, a 10 there, and 10 to power 0 is 1 and a 6 there. So you can think of these numbers as the numbers on top, these 110 and 1 are multiplying with the 2, then you're adding them. So look, 100 multiplied by 2 is simply 200. A 5 multiplied by 10 is simply 50. 1 by 6 is 6. Then if we add these figures, it comes to give us 256. That's how numbers are represented in the Denary system. Practically all numbers. So let me give another example. 1,000. Okay, not with 1,000. Let me say 1,261. So it will start. We'll break it down into a table system. How many numbers? 4, 2, 3, and those are 4 and 4 numbers. So we have 1 here, 2, 6, and then 1. The number we should start as usual, 10 to power 0, 10 to power 1, 10 to power 2, and 10 to power 3. So we can further simplify this table and it will give us a 1000 here and a 100 here, a 10 here, and finally a 1 there. So those numbers in the respective tables will be 1, 2, 6, and 1. 1 times 1000, it's simply 1000. Plus 2 times 100 is simply 200. 6 times 10 is simply 60. 1 times 1 simply 1. Add these numbers and you get 1261. Nothing else. So why am I emphasizing on the Denary system, which everybody knows? I want you to get familiar with how we're changing, like breaking these numbers into the sub-components. That's what I want you to get familiar with, because that will be very important when you start converting from base 10 to base 2. And take a note, this is going to be a very important note if you're trying to convert any number. The base 10 system, because it's base 10, uses 10 digits. This is a very important note. So it uses 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's the base 10 system. What about for the base 2? So the base 2 system, which is the binary system, only uses 2 digits. And what are those 2 digits? You can guess right now. 0 and 1. Nothing else. Only 2 digits. So I was just trying to emphasize that. Now let's move on to the good stuff. Converting. So we're gonna convert first of all from denary to binary. So let's start the conversion. Our first example, we'll start with a relatively simple number. That's going to be 4. So there are 2 methods to this. There's a trial and error method, whereby you see it, trial and error method, and 2 there is a remainder method. Now the difference between these 2 methods is that the remainder method is more general. That means it can convert any type of number system with ease. It's like a system, it's just like an algorithm. You follow simple steps and bam, you get the answer. For the trial and error method, you actually have to see how your numbers are, and you have to like add each time. You have to test this value, will that one work on that? So let me not just be saying these methods, let's actually use one of them. We'll start with the T and E. What's the T and E? Trial and error, as I stated earlier. So for this method to work, you have to do a table first of all, which will just have 3 rows. 1, 2, then you have another. Then divide the table into columns, and that's so. So you start with your base. You list your base first, 2, 2, 2, 2. Then you increase the powers. So this one starts at 0, always at 0, 1, 2, 3, and you can keep on going if you want, but these values won't even matter. 2 power 5. Then you evaluate these values. So 2 power 0 is 1, 2 power 1, 2, 2 power 2, 4, 2 power 3, 8, 2 power 4, 16, 2 power 5, 32. So it's just 1 plus 1, 2, 2 plus 2, 4, 4 plus 4, 8, 8 plus 8, 16, and so on. So for this method to work, you actually follow a pattern of some sort. You simply put zeros on the numbers you ignore, the numbers which won't add up to your value, and you put ones to the numbers which will add up to your value, and you start from the highest. So ones for the numbers which you know will work, zeros from the numbers you know won't work, so these are numbers you ignore. Then you always start from the highest, so start from the highest value. So what's the highest value for 4? It's actually 4. So will these numbers work? They won't. Ignore them. So this will be a 0, 0, 0. 4 will be 1, because 1, when I just multiply 1 times 4, it gives me the 4. Then this will be 0, 0. So you start now from the right going to the left, and you read the number until now they're just successive zeros which are going there. So what do I mean by this? I just mean you read the number going this way. So 0 starts 0, 0, and 1. 4 in the binary system is simply 100, but don't read it as 100, just read 100. So that's 4 in the binary system. Another example, this one a better one which will make you understand the system. So we'll look at the number 71, which is like a big number. So you can draw the table again. So you start from 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, and 2 power 5. Well, for you to make the system a little bit better, you just can't continue. Just continue until you hit the value which is bigger than the value you're trying to convert. So 2 power 6 is just 64. So 64 is still less than that. So now you can go to 2 power 7, which you know is 128. So you know for certain that this number cannot exceed 128. That you know. So 2 power 7 is 128. You can evaluate on your calculator. 2 power 6 is 64. 2 power 5 is 32. 2 power 4 is 16. 2 power 3 is 8. 2 power 2 is 4. 2 power 1 is 2. And 2 power 0 is 1. So you start with the highest. What's the highest value that you know less than 71? So from this table, the highest value which I see is less than 71 is actually 64. So I put the 1 there. Then I look for another value which I know when I put the 1 can at least add up to 71. So you start going back. So then 32 add with 64 gives 71. No. So I ignore that one to be a 0. Can 16 when I add with 64 give me a 71. So you can test that. 64 plus 16. And already I can see that this will give me an 80. So no, you ignore that one. What about an 8? 8 plus 64. So we can just say 64 plus 8. And this I can already see is giving me 72, which is slightly greater. So we're gonna ignore it also. So this is a 0. What about 4? 4 plus 64 is actually 68, which is another value which is lesser. So I can put it. So now this number is actually 8. So we're dealing with 68 now. So we're dealing with 68. What about 2? When I add a 2, can you give me a 71? No, but it will give me a number less than 71, which is 70. So I can add the 2. What about a 1? If I add a 1 to 70, will it give me a number equal to 71 or less than 71? Yes, actually it will give me a number that is equal to 71. So you read the number from here again. So it starts 1 0 0 0 1 1 1, and that is 71 in the binary system. You have successfully converted 71 in the binary system. Should we look at yet another example? Yeah, if you're enjoying the video, you can skip over other things, but let's look at another example for just clarification. Okay, so now let's move on to another example. This time we'll convert a bigger number. We'll convert 381. So first step as usual, draw the table. This one's gonna be a longer table because 381 is a big number. Now 512 is bigger than 381, so yeah, we can end there. And by the way, I just assumed that 2 power 9 is greater than 381. I didn't know that. So we start with the largest number. What's the largest number? Is 256. So we can ignore the 512 because it's bigger. 256 is smaller than 381, so we can add it. Now to make things simpler, we can just subtract 256 from 381. You see why I'm doing this? For faster conversion. 256. So 8 can carry a remainder there. Sorry for using the very simplistic. So 6, this is a 6. 11 minus 6 is 5. 7 minus 2, so 7 minus 5 is 2, 3, and 125. As we can see, we just need now to make a 125, which needs to get added to 256 in order to make a 381. So instead of focusing explicitly on the 381, we can just say, okay, I need to get a 125 using the remaining digits. So how can I get a 125? 125 is bigger than 328. So, 125 is bigger than 128. So I'm not going to use it. So I'm not going to use 128. So we can just put a 0 there. Then I can use this smaller one. 64 is smaller. Yes. So you can continue. What is 125 minus 64? There we get a 1. 12 minus 6 there, and we get a 61. So I just need to make a 61 using these values. So 32 smaller, yes. You can subtract the 32. Pretty sure here you get like a 29. So I need to make a 29 with these values, 16 and 8. Add those two, you get a 1. Oh, now you get 16. 16 is smaller 16 is smaller than 29, so we use 16 with 1. What about 8? So we can subtract the 16 which we have just added here, and we're remaining with 3 and 13. So we can just use an 8 there. 8 is smaller than 13. We just need to make a 5 now. Yeah, 5. Now we need to make a 5. So using this value, make a 5. You can just simply put a 1 here. Do we need a 2 to make a 5? To make it bigger, so 0. You just need a 1, and boom shakalaka, you have your 381 converted to binary. So you can write it 1 0 1 1 1 1 1 0 1. Sorry for all these big ones, but that's 381 converted to binary, which it gives us a 1 0 1 1 1 1 1 1 2 3 4 5 5 1 0 and a 1. By the way, if you want to prove that the answer you've gotten is correct, you can prove it by simply doing the reverse, converting it to denary, but we'll do that later. For the meantime, let's use 1 0 1 1 1 1 1 0 1, and we'll convert it to denary. It should give us the answer to give us 381. We'll use this later on when we learn how to convert to the denary system. Let me just do a last example, this time with a smaller number, like 129. I know I'm using this number 129 because I want to show you that you can just simply master these values and you can do quick conversions in your mind. So we're going to ignore that part of 2, so we're just going to start with 1. 1 plus 1, 2. What is the biggest number which you can start with? It is 128. And what's the difference between 129 and 128? It's simply a 1. So we just need to get another 1. That's all. These values will simply be zeros. So the 129 to the binary system will just be 1 0 0 0. How many zeros? 6 zeros. 0 0 0 1. So you see, as long as you know the second biggest number, just rush to that number, check the number which is remaining, use the remaining values, and yeah, you have your answer. So this was part 1 of the binary system. In the next video, we'll look at how to convert using the remainder system, which is much more general. Thank you for watching, and watch out for part 2.